Okay, Assalamu alaikum. So now this is the paper 2023 October, paper 2. So we are doing the first question. The first question is uh, they gave us some numbers here, some variables a, b, and c. So a, b, c, and abc, and they are saying that prove by exhaustion method that the product of a, b, c is always multiple of 4. So what do they mean by this exhaustion method? So exhaustion means that we have to put some cases, and by the cases, by putting that the cases, different cases, we have to establish that the product of all these variables a, b, and c is equal to 4. So now we will make some cases here. We know that like they already gave us that c is equal to c is equal to 3a plus 1 and a plus b plus c equals to 15. Okay, so obviously we will start from 1. We will check 1, that by putting 1 what are we getting for the value of a. So we start with a. So by putting a equals to 1, we are getting 4 for c, which means like if I put here a as 1 and b as c as 4, so this will be b equals to 15 minus 1, and this will be 15 minus 5, so this will be 10. So I got a, b, and c. So a is 4, a is 1, b is 10, and c is 4. So by this I'm getting 40. So 40 is the multiple of 4. So this is the first case now. 1, 10, and 1, 10, and 4. Okay, now we'll move towards the next case. So the next case is, now I will try for, obviously I will go for 2, and I will check that by putting 2, am I getting the required result or not. So let us try 2. So this will be 7, and so if I put here 1, 2 here, and b is, we have to find b, and c is 7. So this will be 15 minus 9, which will be 6. So let us check here. So if I put 2, I get 7, and for b I got 6. So say 6 7s are 42, and 42 2s are 84. So here you go. So this is also the multiple of 4. So which means that this is our second case, 2, and b is 6, and c is 7. Okay, now we will go for the third case. So the third case is, let's suppose I will try for 3. Obviously I will go for 3. There you go. 3 3s are 9, plus 1 is 10, and this will be b equals to 15 minus 3 minus 10, which will result in 2. So now a is 3, b is 2, and c is this. 10 2s are 20, 10 2s are 20, and 20 3s are 60. So 60 is also the multiple of 4. So there you go. So like 10 and 3, and then 2, and then 3, 2, and 10. Okay, fine. So 3 cases are enough, and like this question is done now. So hence we proved that like the multiple of 3 numbers we are getting by putting like these specific numbers we are getting the result, which the results and the results are the multiple of 4. Now moving towards the next question. The first one is done. Like they already told us here, you may not use all the rows, and they didn't define this thing here, that how many rows should we fill. So 3 are enough. Now we move towards the next question. So this question is from sequence and series, and the first one was also from the sequence and series, like it was a subtopic of the sequence and series chapter from your book. So this is also apart from sequence and series, and now we will look into this question. In sequence series, you must have studied the topic of recurrence relations. So the first one is, this is from the recurrence relation, and this one is from the sigma notation. So now the first part, for part A, you can see that they are asking here for u2, and they gave you this u1 and the formula. The formula is also given. The recurrence relations, the formula is also given, and in the formula they linked this thing with the first one. Like you can see here, un, we have un here, you have n here, and un is representing the number of terms. So now u1 plus 1, this is u1. I need u2, so 1 plus 1 will be 2, and then I'll put this value of u1 here. So the value for u1 is 3. So after taking the LCM of 2 minus 4 upon 3, I'll get this thing. So here you go, u2 is 2 upon 3, and then about for the next one, u3, obviously I will put here, as I told you the formula, I will put 2 here, which means 4 upon u2. So this will be 2 minus 4 upon the value of u2. So this will result in, like after solving this, 3 will obviously go to the numerator. So this will become 12 upon 2. So 2 minus 12 upon 2, 2 minus 6 is minus 4. So u3 is minus 4, and then I will be going for the u4, which they are asking here. u3 plus 1 equals to 2 minus 4 upon u3. So 2 minus 4 upon minus 4 cancel, and this will be 10 to plus. So u4 is 3. Okay, fine. I hope this is now clear. Now going to the next part. The next part is about the sigma notation, and in sigma notation what we do, you can see that they placed they link this ur. So in this part, like it's sigma notation, and they are like it's a sequence, and we have to check the pattern of the sequence. So they're asking for the results from, like, the summation of the results from 1 till 100, but they have put a formula here. This ur is like they are relating this to this formula. So now we will go for the pattern. We will just check the first of all pattern. It's not possible for us that we put, like, we calculate all the values from 1 till 100. So for this we use the sigma notation, and we will just first of all we look the pattern of values we are getting. So like on u1 we are getting 3, and then on u2 we are getting 2 upon 3, and then this, and then this. So you can see that after this, like after 3 values, like this was the first one, then the second, then the third one. So after the third one, the pattern is repeating, like it's repeated, because they are like whatever we are getting, we have to put it here in the formula. And by putting in the formula, we will get the same results. So this will happen, like the same pattern will go. It will keep on repeating itself, like till 100. Till 100 it will keep on repeating itself. So if we ignore the first one, like this, okay, forget about the ignoring. Like if you go for the patterns, so this is the pattern of 3 numbers. You can see this is the pattern of 3 numbers, like first, second, and third, and then after the 3 numbers it keep on repeating itself. So they are total, we have like 100 numbers from 1 till 100, and we will check that how many repetition we will be having. So by dividing this, we are getting 33.33, which means that 3 multiplied by 33, if I go like this, so 99 times we will face the repetition, and the first number is 3. Like the last, like after the 99 term, it will go again for the first term. The first term is 3. So it means that after the 99 you will go for the first term. Asking for the summation. So summation means like we will do it like this: 33 times we will have this pattern, and in the last we will having this one, the first number again. So now if I do the multiplication thing here, so this will be 3 plus 2 upon 3. I'm just doing it on my calculator with me. It's not on the screen. Minus 8 I'm getting. So minus 8 is the answer. I hope the concept is clear. So now we will move towards the next question, which is from the trigonometry. And in trigonometry, they are asking for the angles. In the first part, they are asking for the angles. So the basic concept of the trigonometry is like whenever you are having this kind of questions, so your main goal is to like keep a trigonometric ratio on one side and a number on the other side. This will be your main goal, and if you are unable to do this, then try to make a quadratic equation on this side, having one trigonometric ratio, and on this side try to get a zero here. Okay. And the third thing is, if you are unable to get one number and the trigonometric and the quadratic equation, then try to make an equation like take it should be like this. If you take a common sort of an equation, like if you are getting two trigonometric ratio, so it should be sort of like this sort of a situation with the zero on this side. So these are the three kind of three ways to solve these sort of questions. Now we will go for this one, the first one. So the first one is 2 tan theta plus this one. So you can see that there are two different trigonometric ratios here. Two different trigonometric ratios we have here. So we will try to convert this to one trigonometric ratio, which seems to be impossible, because if I convert this tan to sine upon cos, and it will give us this thing. And sine, we cannot convert sine or cos, like there is no such formula for the sine or cos. So what we will do here, take the LCM. So LCM will be like this: 3 sine theta cos theta equals to 0 upon cos theta. Now as you can see that we took the impact of this cos here in the question. We will move this cos to the other side, and it will become 0. And as I told you that we will try to bring to a situation like the three situation which I told you earlier. So here I have this sine and sine as a common, like no trigonometric ratio, no specific one trigonometric ratio. We are like bounded by two kind of a trigonometric ratios. So I will just take sine as a common from there. So I will be left with 3 cos theta equals to 0. So this is the third form which I told you. Now if I have this thing, what I will do, I'm successful in this by getting this thing. Okay. So after getting this thing, this will be sine equals to, I can do this, sine equals to this 0 and 2 plus, I will split this into two equations. So basically whenever you have a trigonometric ratio of sine or cos and you need to find the basic angle, so remember, if you have here 1, -1 or 0, so the basic, you cannot take the basic angle, you cannot calculate the basic angle. So you have to remember from the graph, you can remember this, like where are the values on which you will get these numbers. So this is the standard sine theta. There is no, like the angle is like a simple theta, it's not like stretched by anything. So the standard graph for sine is this is 0, this is 90, and this is 180, and this is 270, and this is 360. So where are we getting zeros? We are getting 0 on 0, we are getting 0 on 90, we are getting 0 on 360. So for this, for sine theta, like the answers will be 0, 180 and 360. Now moving to this one, cos theta. We will just adjust this, 2 will go to the other side, and then it will become this. So now you can see, we will just check the quadrants where this, hold on just a minute. So you can see here that the answer they are asking for, the 0 is not included, it's excluded. 0 is not included, so we will just exclude this 0. So the answer will be for sine, like for like we get the partial answer, which is 180 and 360. Now we'll go for the second one. So for the second one, okay, so we will just check the quadrants where cos is negative. So cos is negative in the second quadrant, and in the third quadrant cos is negative. So we will just now, after this, after identifying the quadrants, we will take the we will calculate the basic angle. And remember, do not consider negative sign for calculating the basic angle. Okay, we will calculate the basic angles on just positive sign. Okay, so the negative sign will only help you to identify the quadrants. So now cos 2/3 is, let me calculate this. Cos negative 2, cos inverse 2/3 is 48.18, and they restricted us to 1 decimal place. So the answer is 48.2. Now we'll place it here, 48.2 and 48.2. Now we'll calculate the answers, the angles which they are asking for. This is the answer, and this one is the answer. So how we will calculate this thing? So the first one will be 180 minus, like our requirement is, this portion is our requirement, this portion is our requirement, and the second is, this one is our requirement, this one is our requirement. So this will be 180 minus 48.2 and 180 plus 48.2. So the answers are 132 point, hold on, let me calculate it. Yeah, 180 minus 48.2, so it's 138, it's 138.8, it's 138.8, and the other one is 180 plus 48.2, and it's 228.2. Okay, I hope you got this one. So now moving towards the next part, let me remove this. Remove this one. Okay, so the second part is they are asking for, you can see, okay, so now in these sort of questions, usually you have to notice this thing, that you can see that you have a 2 here, you have a tan here, you have a 3 here, you have a sine here. The only difference is they just change the angle, which makes it so simple. And like, you will face these sort of situation, these sort of things in many questions, especially in trigonometry. I'm talking about the trigonometry. Okay, so now this makes it very easy. They are asking for, again they are asking for the smallest positive solution of this, which means they are asking for the angles. So the angles which we got, also check this thing, they use the word of hence. Hence means that you have to carry from the last answer, you have to carry, no working required. Whatever we did in the previous one, like, do not repeat the working. Hence means like you have to start from where you left, you can pick the answer from there and you can put it here and you can solve it. So by the way, uh, if you want to check that you got the right answers or not, you'll put the answers here, the angles which you got here. So I'm talking for the previous part right now. So you by putting the angles here and solving this side, you must get whatever you have here on this side. So in this question you have 0 here, so by putting the angles here you must get 0. So this is the way to check that the answers which you got, the angles which you got, are correct or wrong. So now the answer for the previous we got were 180 and 360 and 131.8 and 228.2. These were the answers which we got for the previous part. So they are asking right now what they did, and by the way, these were equal to theta, and theta is now being replaced by 2x plus 40, which means 2x plus 40 equals to all these angles. So now they are asking for the value of x here. They ask, like, the angle is x here, then this number x is the thing which they are asking for, and they are asking for the smallest positive answer. So obviously the smallest positive thing is from this is the smallest one, and we'll put it here. The rest, if we put the rest, we will get obviously we will not get the smallest one. So it will be 131.8 minus 40 upon 2. So the answer will be, let me calculate this, 45.9 will be the answer. Okay, I hope this is clear. Moving towards the next one. Okay, so this question is from remainder and factor theorem, and in this question they gave us this thing, like this is the equation, and they are saying that this is the factor. So remember, whenever they told you that this is the factors, anything is a factor of like an equation, that means that you have to make that thing equals to 0 and calculate the value of x. So this will turn to this minus 1 upon 2, and then after getting the value for x, you can put it here, and by putting it here you will make this equal to 0. So like this is the like in the factor theorem, whatever you put here, like obviously it will be the factor, and after it's defined that it is the factor. By putting it here you will get 0, the remainder must be 0. So this is the main concept of the factor theorem. So here we are having this minus 1 upon 2, which is the factor of the equation. So we'll put it here, minus 1 upon 2, minus 1 upon 2, and minus 1 upon 2 plus b equals to 0. Okay, so this will turn to 4 into minus 1 upon 8 plus a upon 4 plus 29 upon 2 plus b equals to 0. Okay, so this will turn to minus 1 upon 2 plus a upon 4 plus 29 upon 2 plus b equals to 0. So a upon 4 plus b equals to, this will turn to, like, the denominators are same, so then we will just solve the numerators. So this will turn to 28 upon 2. So moving to the other side, we'll move this to the other side, and it will turn to 28 upon 2 will be 14. Should be 14 here. Now taking the LCM here. So the LCM will be a plus 4b upon 4 equals to 14. Moving this to the other side, a plus 4b equals to 56. I hope this is clear now. This concept is clear. The question is clear, and the concept is also clear. Now doing the next part. So the next part is given also that when f of x is divided by x minus 2, the remainder is minus 25. So this is a remainder theorem now. Which means that whatever you put here in x, you will get a remainder which will not be 0. So now they are saying that by putting this x equals to 2, we will get this thing. So we have to put this x equals to 2 here.
find a second simplified equation linking a and b. So this will be like 2 cube, making this thing equals to 0, x equals to 2, and this will be a2 square minus 29 2 plus b equals to minus 25. It's given here. So this will be a 2 to the power 3 is 8, 8 4s are 32, and then 4a, and then 29 2s are 858 plus b equals to minus 25. So 4a plus b equals to minus 25 minus 32 plus 58. 2 and 5 will be 7, and minus 3 minus 2 will be minus 5 plus 58, so it turns to 1. So 4a plus b equals to 1. Okay, so this was the second part B. Now moving to the next part C. Hence, again they use the word of hence, which means we will like take the numbers, the answers from the previous one, and then we will solve them. So they are now saying that hence find the values for a and b, which means we have two equations. This is the first equation was a plus 4b equals to minus 56, and the second equation is 4a plus b equals to 1. So now b equals to 1 minus 4a. This is, I just arrange this one, make the subject here. I'll put in the second one 1 minus 4a equals to minus 56. So a plus 4 minus 16a equals to minus 56, and this will turn to minus 15a equals to minus 56 minus 4, which means 60. Cancel 4. So a equals to 4. There you go. The answer for a is 4, and we will put this here to get the value for b, which will be b equals to 1 minus 4 into 4 minus 15 is the answer. So I hope this is clear. This was very easy one. Now factorize fully factorize them. This is the last part. Fully factorize. What do they mean by this? Actually, in this chapter, there are some concepts. The first one is for the remainder theorem, the second is for the factor theorem, and the third one is when you get the whole equation, the whole cubic equation, then you will factorize it to get all the three values for x. Okay, so the values for a, first of all I'll just make the whole equation. So the equation is 4x cubed plus the value for a is 4, so this will be 4x square minus 29x, and the value for b is minus 15. So this is the whole equation which we got here, and we already know that 2x plus 1 is the factor. 2x plus 1 is the factor. We already know this thing, so which means that we have one value of x, and the highest power is, you can see, 3, so which means that we have to find three values of x. Out of three values we already have one value, so the two values are remaining. So we have to find the remaining two values. So how we will find the remaining two values? The remaining two value means that we have to use the we have to get a quadratic equation, and then we have to solve the quadratic equation. So there are two methods. The first one is the division method. This is the division method, and then I will also do this question by the synthetic method. So the division method is 4x cubed plus 4x squared minus 29x minus 15, 2x plus 1. Okay, leave the synthetic, we will just do this by division method. So the division method is like, now we will target, how we will do this. We have to target the highest powers, and we will remove the highest powers one by one. Now the numbers, the coefficients, like we have to finish the whole power, the highest power. So the highest power here is 4x cubed. So divide this 4x cubed by the first number. The first number is here, 2x. So what we are getting, 2 2s and 2s, so 2x square, which means that if I write 2x square here, and then I'll multiply 2x square with this one. I will get 4x cube plus 2x square. Cancel down, and 4x square minus 2x square will result in 2x square. Now the highest power is x square. Now we will just solve this, divide this by the first number, the highest power. This is the highest power and this one is the first number. So cancel down 2 2 2 2. So the left thing is x, which means that we have to multiply this by x. So by multiplying this we'll get this. Now cancel down this, minus 29 and minus x. Remember we will consider this symbol, okay? So minus 29 and minus x will be minus 30x plus 5. Okay, so now this is 15, this is 15. Okay, so now the first number is the highest power. Here we have minus 30x. So minus 30x divided by, you have to consider the symbol also, you have to consider the symbol. So the symbol is minus 30, so minus 30 divided by 2x. Cancel, cancel, cancel. Minus 15 is the answer, which means we will put minus here, minus 15. We will multiply this by minus 15. So minus 15 times 2x is minus 30x. And then we have, hold on, I just did a mistake here. This is, be aware of this kind of mistakes. So this is minus, this is minus. So minus 15. Cancel down, cancel down, cancel. So the quadratic equation which you got is, the first one is 2x plus 1. This is the simple factor. And the quadratic equation which you got is 2x square plus x minus 15. Okay, so now we need to factorize this. And how to factorize it? We'll multiply this, the first and last terms. So the first and last term, the product is minus 30 and the middle term is 1 plus 1. So which means that we'll make the factors. So we have 2, 5 and 3. Now we will arrange these factors into such two teams here, like one team will put one team here and one team or one pair we will put here. And when we multiply these two teams or pairs, we must get this product, and when we add them we must get this thing. So this is the this will be a perfect pair then. So now the middle term is 1, which means that we will make a pair of this 3 2 and 5. So which means that 6 and 5 minus 5. So 6 times minus 5 is minus 30 and 6 minus 5 is plus 1. So there you go. So this is the pair 6 and, hold on, 6 and minus 5. So 6x and minus 5. And now taking the common, 2x is the common, x plus 3 and minus this. And remember, in factorization these numbers must have to be same. So now x plus 3 is the common, and the remaining is 2x minus 5 and 2x plus 1. There you go. So this is like, now we've fully factorized this thing. Okay, so this question is done. Now moving toward the next question. This is the next question now. Question number 5 is from the logs, and the first question is it's the exponential function, and the second is from the logs. So how we will solve in logarithms? You must have learned this thing, like whenever you have a power, an unknown in the power, the first way is like try to make bases same. So like if you cannot make the base same, then try to make the power same. And if you cannot make the power same and the power is unknown, which means that you have to bring power to the, like from the you have to move power from here to the bottom. So what will you do? You need log. So in the first part we will apply log on both sides. So let's suppose I apply this thing LG and LG70. So according to log rule, this I can move log A to in the start, and now LG70 upon LG3, which will turn this to 3.867. 3 decimal places they are asking for. So this is the answer for the first one. Now for the second one, we will move logs to one side, and you can see the bases are same, so it will look like this. 4 equals to log 3 5b minus 3 log 3b. So we can apply the formula of the logs, but remember we can only apply it when we have two logs and the bases are same. The bases are same here. These are few checks, and there must not be anything in the start. So we have a number which is 3, and it's in the start. We will move this 3 according to log rule. This 3 will move to the power. Now the checks are, the first check is the bases are same, the second check is there is nothing in the start, and the third check is whenever there are two logs there must be a positive or negative symbol in between. If you have a between two logs, if you have a multiplication symbol, then you cannot apply the formula. Or if between two logs, if you have a division symbol, then you cannot apply the formula, the rule. So now we will apply the rule. The rule is whenever there are two logs with the same basis, then you and a negative symbol in between, then you can turn this to a singular logarithm, and these values like these, you can write it like this. So now it's like, I'm just arranging this. So okay, so now I have to find the value. I have to solve this and to find the values for the unknowns, which is b here. So now I'll apply the rule, which is how we convert from a logarithmic form to exponential form, and that is, the rule is, this is basically, this is the base. So I will write the base here, and this thing is the power, the exponent. I will write it here, and I have to move this to the other side. So this is the formula, this is the rule. So 81 equals to 5b, and b will be cancelled, so it will turn to b square. So this will be b square equals to 5 upon 81, and then taking the root of this, so this will turn to 5 upon 81. And they didn't ask for any restrictions here, like the decimal or something, so we can write it like this. And the thing is, okay, so they asked for the exact value, so the exact value is this. We have to write it like this whenever they ask for the exact value. So this question is done now. So this is actually the second one. Okay, this is the sixth one. I forgot the previous one. So this is, in this question you can see that they are asking for the trapezium rule, which means that this question is from the integration. So trapezium, they are asking for the trapezium rule, and for the trapezium rule we will make a table. So it will be, if I make the table here for a clear understanding, I have the values 1 2 3 4 5 6 values. I have 1 2 3 4 and 5 and 6. So the first value is here, starting from the usually this one is the x-axis, this one is covering the x-axis, so the x-axis, and this one is covering the y-axis, which we usually said that is the frequency, so it's covering the y-axis. For the y-axis, it starts from here, from 0, then 1.52, then 2.74, and then 3.12, and 3.08, and then we have 0 here, and the x-axis is 0, 3, 6, 9, 12 and 15. So the formula is b minus a upon n is the height. So the maximum number here is 15 on x-axis minus this thing upon the number of trapeziums we have. So the number of trapeziums we have 1, 2, 3, 4, 5 trapeziums we have here. So the height will be 3. This is the height. So now the formula is h upon 2 and then adding the first on y-axis and the last one on y-axis. So the height is 3, the first one is 0, the last one is 0, then 2 multiplied by everything inside, 1.52 plus 2.74 plus 3.12 plus 3.08. So 3 upon 2 and then whatever we have here. So the result is 31.38. I hope this is clear now. The first part is clear. In fact, yeah, the first part is clear now. So now moving towards the next part, let me clear this. Moving towards the next part. So the next part is they're asking for, hold on. So in second part they are saying that the water in the river is modeled as flowing at a constant rate of constant speed of 1.5 meter per second across the whole of the cross section, means across whole the area, which we calculated in the first part. Use the model and the answer in part A to estimate the volume of the water flowing through this section. This section means the area which we calculated in the first part of the river each minute. So in the first part the area was 31.38 and through this area water flows with a speed of 1.5 through each minute, means 60 seconds, because they mentioned here it's meter per second. So we have to write this into seconds. So now the answer which we will get by doing this is 2800 and this is the answer. And they are saying for the volume. So the unit for the volume is cube. So this was the second part. Now moving towards the third part, assume the model, state giving a reason for your answer. Whether you answer in part B. Okay, hold on just a minute. What's the answer? 2800. Okay. So in part B is an overestimate or an underestimate of the true volume of the water flowing through this section of the river each minute. For B part, one thing you should remember, that the answer by multiplying this is 2, 8 and 2, 4. As they asked for two significant numbers, that's why I wrote it like this, okay? Because they asked for the two significant numbers. So the third part, the last part is, you can see that it consists of 1 mark and they are asking for the reason. So the reason is like the area of the trapezium rule often underestimates the actual area or volume when compared to the true value. So I think this is clear now, because if you consider the trapezium rule with the true volume, so it always underestimates it. So I hope this is clear now. Now moving towards the next one, the next question is, there you go. Now this is from the circle theorem. Okay. So here in this question we have a straight line. This question is from equation of the circle, and we have a straight line which is tangent to the circle here on this point on N, and we have the center of the circle which is this X. So now they are saying, show that the equation of the line, of the straight line passing through X and N. So passing through the X and N means that this line, they're asking for this line, they're asking for the equation of this line. So you know about the concept of, like, while doing this topic, there is a concept, and the concept is whenever there is a tangent with the radius, like there is a tangent which is a line, a tangent line. This is a line, tangent line. Here on this point is tangent, and with the radius. So if it's tangent with the radius, so that means that it's making 90 degrees here. It's making 90 degrees here. Okay, so now they're asking for the line. So now for the equation, they're asking for the equation of the line. So for the equation of line, we need this equation. This is the equation of the straight line. We need to make this equation, and for this equation we need two things: the gradient and the coordinates. So the coordinates are already, we have the coordinates. They are the coordinates x4 and -3. For the gradient, as it is tangent, which means that we will pick the gradient from this line, which is 5.2, and for the tangent, we will reciprocate this and with the change in symbol. So -2/5 will be the gradient. Okay, so now we will make the equation. The equation of line is y minus y1 equals to gradient x minus x1. So y minus -3 equals to -2/5 and x minus 4. Y plus 3 equals to -2/5. X plus this will turn to this 8/5. Now as the denominators are same, the denominators are same, so we'll cross multiply them, like we will change the side of the denominators. So this will be 5y plus 15 equals to -2x plus 8. So 5, arranging the way they asked for, y 2x plus 5y plus 15 minus 8. So 2y plus 5y plus 7 equals to 0. So there you go. This is the required one. Okay, so this is done now. The first part is done. Now moving toward the second part. So the second part, let me clear the screen. So the second part is, here you go. The second part is, now they are saying here in the second part to find the coordinates of n. Find the coordinates of n. So it's very easy. It's a basic concept that whenever there are two lines and they are asking for the coordinates, and the lines are meeting, they meet at on any point, which so that means that we have to solve them simultaneously. So here the equation is, the value for y is this, so we will substitute this in the below equation. So this will turns to 5/2x minus 55/2 plus 7 equals to 0. So now taking the LCM, 2 is the denominator, so this will turn to 4x plus 25x minus 5 5 is a 25, 5 5 is a 25. So this will be 27 plus 14 equals to 0. So this will turn to 29x, and let me calculate this. Minus 275 plus 14, so minus 261 equals to this. X equals to 261/29. So divided by 29 will give us 9. So x is equal to 9. And for the other one, we will put this in any equation. We have two equations. Preferably we will put it here because we already have x, y as a subject here. So we'll put it here. Y equals to 5/2 and then 9 and minus 55/2. So the result will be -5. So there you go. So these are the coordinates for n. Now the equation of circle, which is very simple. This is the equation of circle, the standard equation of circle. Standard equation of circle is r squared. So x minus a is 9. A means, like here we have the center. The center is 4. So x minus 4 and y minus -3, and the radius. Now talking about the radius. So that radius, how we will find the radius? So these coordinates, we have these coordinates 9 and minus 5. So we will apply the distance formula over this, which will be 9 minus 4 square plus minus 5 minus 3 square. So this will be 9 minus 4, 5 is this 25, and minus this 4, 4. So this will be 29. So the distance is 29, but the distance is root 29, which means the radius is this. But the formula, according to the formula, we put a square over it, so it will be 29. So this is the equation of the circle. This will turn to positive, so this will be like this, y plus. Okay, so this is the equation of the circle. So this is done now. Question number 7 is done. Now moving towards the next question, which is question number 8. And now this question is again from the sequence and series. A lot of questions, like mostly what we see, what I have noticed, like 2 or 3 questions, and in some cases like 3.5 questions come from this chapter. So sequence and series is a very important topic. So now coming to this one, this question number 8. Okay, so from the question, you can see that in the question they are discussing, in a large theater there are n rows of seats where n is constant. The number of seats in the first row is A. Okay, then in each subsequent row there are 4 more seats. Like you can see here, plus 4 plus 4, 8. So it will be like this. If I make the sequence, it will look like this. So it is an arithmetic sequence, and they clearly mentioned it here. So then they say that given that the total number of seats in the first 10 rows, like 1 2 3 4 5 6 7 8 9 10, in the first 10 rows, it means they are adding them. So it is like they are referring to the sum of arithmetic sequence. So sum of arithmetic sequence is sum of 10 rows equals to n upon 2. So n is 10 into 2 into A, the first row, n minus 1. I'm writing down the formula and also plugging the numbers. So D is as the increase in the seats is, they are increasing by number 4. So there you go. So the sum is 360. 5 2A plus 9 4s are 36. So 5 will come to this side. The 360 by 5 will be 72 equals to 2A plus 36, and 72 minus 36 upon 2 will be 18. So A is 18, the first row is 18. So if the first row is 18, then the second will be 22, and the third will be 20. The third will be 30. Sorry, pardon, hold on. Third will be 26. Okay. So this is for the first one. Now for the second one, they are saying, given also, there you go, this is the one. Given also that the total number of seats in n rows is 2 1 4 6, show that. Again, the sum formula, they are using the sum formula. N upon 2, n is unknown. Now this time n is unknown. 2A plus n minus 1, and the distance is, like they already mentioned it, it's 4. It's constant distance. So summation is 2146 equals to, and the value of A, we got the value of A, which is 18. So 18 times 2 will be 36. So n upon 2, and 36 plus 4n minus 4, and this 2 will come to this side, will multiply with the 2146, will result 6 2s are 12, 1 4 2s are 8 9, 2 1s are 2, 2 2s are 4, and then equals 2 n, and 36 minus 4 will be 32, minus 4 plus 4n. So now we'll arrange this by multiplying this. N with 4n will result 4n square, and then with 32 will result in 32n, and then minus 4 2, this equals to 0. There you go. Now we'll take common 4 as a common, which will result in this 4 1s are 0 7 3. So this is the result and the requirement which they were asking for. So we finally get this one. Now moving to the next one. Hence, so it means we will use the previous answer. Hence state the number of rows of seats in the theater. So now first of all we will solve this one, because n is representing the rows. So like simply like we can solve this one by putting the values in the quadratic formula or by Middleton break. But Middleton break seems like it will give us a very big number, so it seems sort of like it's a time consuming thing. So we'll just put this in the formula, the quadratic formula, b square minus 4ac upon 2a. So it will be minus 8 plus minus b square is this one, and then 4a is 1 and minus 1073 upon 2a, which is 1. So now putting this in the calculator, I'm just solving this in the calculator. So root 64 plus, like this will turn minus will turn to this to plus 41073. 66 is the root, so this plus upon 2 and minus 8 minus 66 upon 2. So minus, we will ignore this one, the output will be minus, so seeds can't be in minus, and is representing the total number of seeds, so seeds can't be n is representing the number of rows, so rows can't be negative. So this will be 66 minus 8 divided by 2 will result in 29, so n is 29 here. Okay, so I hope this is clear now. N is 29. Now moving to the next one, the last part of this question, which is find the maximum number of seeds in each row. So already we have this, like the formula. What's the formula? The arithmetic sequence is, this is the arithmetic sequence, and the formula for the arithmetic sequence is this into d. So the maximum number of seeds, hold on just a minute, yeah, a equals to 18, and then n is 29 minus 1 and d is 4, so the maximum number of seeds is 130. So I hope this is clear now. I'm moving to the next one, the next question number, yeah, this one, question number 9. So now this question is from integration. This is from integration, and this is the equation of the curve where x, the value of x is greater than 0. Find using calculus the range of the values of x for which y is increasing. Okay. So if we look at the graph, at the curve, there are, like, we are seeing two views. The first, the first view for the y, like the restriction which they made here is, like, we have to find the values for y, for x for which y is increasing. So we cannot put the values, like, first of all we have to identify the values of y, or the point, the number from where y is increasing. So you can see that y is decreasing. Now this is the point that now after this it's increasing. So basically there is a concept, and you have learned this concept before, that in the curve, when like there is a stationary point or the turning point, so on the turning point or stationary point, or the minimum or the maximum point, the gradient is 0. So we will calculate the gradient of this. We'll find the gradient. First of all, we will, like, go for the gradient. So the gradient is dy upon dx, and this will be, it will look like this then, 2x, and then like this one is 9x to the power of 1 upon 2. 1 upon 2 will come to the start, 1 upon 2 minus 1, and then this will 13 will become 0. So this will become 4 upon 3 x minus 9 upon 2, and this will become 1 upon 2 minus 1. So 1 upon 2 minus 2, x is minus 1 upon 2. So this will come to the power is negative, so it will come to the denominator. So it will look like this. Now on the stationary point, you know this, that the gradient is 0. So we'll put a 0 here, and take the LCM of the denominator. So the LCM will be, this will be the LCM. How we take the LCM? We make the denominator same. So here 3 is missing, so we'll multiply this by 3, and here in the denominator
2 root x is missing. So 2 root x will be multiplied with that both the numerator and the denominator. So 4 2s are 8, and x times x to the power of 1 upon 2 will result 1 plus 1 upon 2. So x is 3 upon 2 now. So x 3 upon 2, we have x here, and then 9 3s are 27. There you go. Okay. So this will goes to the other side, multiply by 0 will turn to 0, and it will look like this. 27 upon 8 equals to x to the power of 3 upon 2. So now the best way to, like, if you can see here, we want x, and the best way, like x without any power, just to the power of 1. We need x with 1 power, like, but here we have 3 upon 2. So the best way is to get rid of the power is take the multiply the power with the reciprocal. So the reciprocal is 2 upon 3. According to maths, we have to put the reciprocal also on the other side, so it will be x. Now here, just have a look here what they said. Solution relying entirely on the calculator are not acceptable. Okay, fine. So now you must be familiar with the indices. So what we do in the indices, you can see in the power in the denominator we have 3. So we will just break down these numbers into the power. So 3 to the power of 3 is 27, multiplied by 2 upon 3, and then 2 to the power of 3 is 8, multiplied by 2 upon 3. So now 3 and 3 cancel. 3 to the power of 2 is 9, and 2 to the power of 2 is 4. So x equals to 9 upon 4. Fine. This is the turning point of x. Okay, this is the turning point of x, and from this point x will be like the nature of x will be, the nature of y will be, you'll see there will be change in the nature of y. So this point is 9 upon 4 for the x, and for the y it's simple. Like they didn't ask for the value of y, they just asked for the value of y must be with the increasing trend. So this is the point, from here y will be in an increasing trend, and this is the value for x. So the range of x is this. So the range will be greater than 9 upon 4, because you can see that it's continuously on an increasing trend from this point. So x, the answer is x is greater than 9 upon 4. So this is for the first one. The first part is done. Now moving to the next one, the second part. So the second part is the point P lies, hold on, the point P lies here. The point P lies on C and has coordinates of 940. Okay, L is tangent to C at point P. Fine, L is tangent. Yeah, we can see that it's tangent here. The finite region R in the this is the finite region, like it is starting from here, from this point, and it's ending here. So this is the finite region of R. Is bounded by the curve, the line, the x-axis and the y-axis. Okay, so find using calculus the exact area of R. So basically the concept is, like, first of all we need to find the shaded region, but as they already said here that we have to apply the calculus, and by the calculus, it's a concept in the calculus whenever we want to find an area. So if let's suppose we apply we first of all we have to find the integral. We have to find the integral of the curve. We have to apply the integration on the curve, and with the integration we have to put the limits, upper limit and lower limit. So here we can see that the shaded and the limits which we will apply on the curve will represent the area straight below it, straight beneath it. It will represent that area. So if I integrate the curve and put this limit 9 on it and 0 on it, so it will give me the whole area, this whole area. It will give me this whole area, this whole area. It can't be tilted, like it can't give you a tilted area. Like it cannot be like this, that if you apply here, it will give you this area. No, it will straight go down and it will cover all the area beneath it. Okay, but we need the other shaded region. So the concept is like, what's the concept here is, we will like apply the integration over it, which will give us the whole area. Then you can see here, as it's a straight line, so we will find that the area of the triangle, the right angle triangle, and then we'll subtract it from this, the blue one, the whole area, and then we'll get the shaded part. So first of all, we have to integrate it, the curve. So the integral of the curve, we have to integrate it. So integration will be 2/3 x 2 plus 1 upon 2 plus 1 minus x to the power of 1/2 plus 1 upon 1/2 plus 1 plus 13x, and the limits will be 9 till 0. So it will look like this: 2/9 x to the power of 3, and then let me calculate it. It will be minus, okay, leave it. It will be like this: 3/2 upon, taking the LCM of the denominator, so it will be like this: 3/2 and plus 13x, 9 and 0. So this 2 plus 1 becomes 3, and then we multiplied this 3 with this 3 to get this 9, okay. So this will be then 2/9 x to the power of 3. This 2 will goes up because it's a double fraction, like this is the main fraction, and beneath this one we have 3/2, so this 2 will go upward. So it will then being multiplied with this, so 9 2s are 18 upon 3, this and this, 13x, 9 0. So now we will apply 9 over this. We'll put a 9 in whole of this, and then we'll put a 0 in whole of this. So you can see, by putting a 0 here, here and here, we will get a 0, because 0 will be multiplied with everything, so it will turn them to 0. So 2/9 into 9 cube minus 18, so this will turn to 6. So 6 and 2/9 square. Sorry. 6 into 9 square plus 13 into 9. Okay, there you go. So now I'm just calculating this whole thing. So 2/9 into 9 square minus 6 into 9 square plus 13 into 9. Okay, sorry, I did a mistake here. Hold on, I just missed this. this one. Hold on. This will be 6, 9 to the power of 3/2 plus 13 into 9. So it will be, just doing the calculation, so 2 into 9 to the power of 2 minus 6 into 3 to the power of 2 into 3/2 plus 13 times 9 will be 117. So now 2 into 81 plus cancelled, so this will become 162, and 6 into 27 plus 117. So 162 minus 6 into 27, and plus 117 will result in 117. So this is the answer for the shaded part, the whole shaded part. Now, as you know that this part is 9, this part is 9, so we need to find this one. And how we will get this one? The only way is to make the equation of the line. This question really need working, because they are giving you 8 marks for this question. So we need to find this one, this area, like this position, this value. So how we will get this one? So we need to make the equation of the line. So the equation of the line is, as earlier told in the previous question, is in one of the previous question, we need m and xy. So we have this xy with us, and m. How we will get this m? Like in the part, hold on. Now the easiest way is to find the gradient on any point, like like now there's a concept in the curve. If I make a curve, on every point the gradient will change. You can see there is a change. The on curve, on every point the gradient will change. So if I just calculate the gradient in terms of x, any variable, and I put any point in the gradient, I will get gradient on that point. So in the first part, we just calculated, we just did the gradient. The gradient was dy upon dx. Okay, so this is the equation basically. Now I'll put 9 here, and then 9 here. So it will result in 21 upon 2. So the gradient will be 21 upon 2. So 21 upon 2 is the gradient. Now I'll make the equation of the line. So the equation of the line will be y minus y1 equals to the gradient x minus x1. So y minus 40 equals to 21 upon 2, and x minus 9. Okay, so y equals to 21 upon 2x, and this is 9. So this will turn to 21 times 9 will be 189 upon 2 plus 40. Y equals to 21 upon 2x, and hold on, 189 upon 2 plus 40 will give us 109 upon 2. So now I have to find the x-axis, x coordinate. So x coordinate means like it is intersecting the x-axis. So it means that I have to find x coordinate, x0. So y will become 0. 21 x upon this equals to minus this. Moving this to the other side will result it like this, upon 2. So cancelled. So 109 upon 21 equals to x. So 109 upon 21 equals to 109 upon 21. Okay, so this is the same thing. Okay, fine. So this is the value for this is 109 upon 21, which means the total is 9. Like till here the total is 9. So how I will get this portion? This portion. So it's simple. 9 minus 109 upon 21 will give me this thing. So minus 9 minus 109 upon 21 will result this in 80 upon 21. So the length of this is 80 upon 21, and the height is 40. By the way, the height is 40. So what we will do, this is the total area, the shaded part, total shaded part. We will subtract the triangle. So the base of the triangle, the height of the triangle is 40, and the base is it's 9 minus 109 upon 21 results 80 upon 21. 80 upon 21. Let me calculate this one on the calculator. 40. So I'm getting 857 upon 21 means 40.8. Okay, so this is the answer, and this is now done. Now moving towards the last question. This is the last question now. Hold on. Yeah, this is the last question from the binomial expansion. Okay, so from the binomial expansion, the first one is like they simply want, in the first part they are saying that the answer they're asking for finding the ascending order of power x, find the ascending powers of x, the second, third, and fifth terms of the binomial expansion, which means that if I expand this one, so this is the first term, then 6c1 3 to the power of 5, 2x to the power of 1, this is the second term, 6c2, hold on, 6c2 3 to the power of 4, 2x2, and this is the third term, and then the fourth term, 6c3 t3 to the power of 3, 2x3. So it's like this, the 5 6 5 4 3. Okay, then 6c4 3 to the power of 2, 2x to the power of 4, then 6c5 3 to the power of 1, 2x to the power of 5. Okay, so now the first term, the first term, then we have, they asked for the second, third, and fifth term. So this is the second term, this is the third term, second, third, and fifth term, and then 1 2 3 4, and this is the fifth term. So by putting them in the calculator, I will get the answer 6c1 times 3 to the power of 5 into 2. So 2, the second term is 2916 with just x. Okay, so now then the second is 6c2 3 to the power of 4, and 2 to the power of 2 means 4.
So this one is 4860 x square, and the last one is 2160 x to the power of 4. So there you go, we have these answers. This was for the first part, and then they are saying find the value of x. Find for a particular, okay fine, for a particular value of x, these three terms form a consecutive terms in a geometric sequence. These three terms form a consecutive in geometric sequence. Find the value of x. So which means that they are saying that they are consecutive in geometric sequence. So we have to find the value of x. So in consecutive, like when they say that in geometric they are consecutive, so consecutive means that the ratio must be same, which means that it will be like this: 4860 upon 2916 with x square upon x, and the other one is, as they are consecutive, so the other one will be 2160 x to the power of 4 upon 4860 x to the power x square. Cancel down them, this, cancel this, and then simplifying them, like 4860 divided by 2916 will give result in this, and the other one is 2160 divided by 4860. This will give us result in this with x to the power of square. Cancel down these things, and this will be, so this will be 3 ones are and 3 threes are, so 15 upon 4 is the answer for the value of x. Okay, so this is done now. The second part is done. 15 upon 4 is the value, answer which we got. Now moving to the next part. In the next part they are saying In a different geometric sequence, the first term is sine square theta, and the common ratio is like r is a is sine square theta and r is 2 cos theta, and sum of infinity is 8 upon 5, which means that 8 upon 5 is equals to, we can write it like this, no need to write because we have, okay, fine. So we have to show this thing, which means that we will use this formula. A is sine square theta upon 1 minus 2 cos theta, the value of r, and then 8 upon 5. So we'll do the cross multiplication, and you can see here that there is no, like, there's just one trigonometric ratio, which is cos, which means we have to remove this sign. We have to convert this sign, the sine square. We have already sine square, so we can convert this sine square into 1 minus cos square. So it will be like this, 5 will be multiplied here, and we will convert this to 1 minus cos square equals to 8 into 1 minus 2 cos theta. So now I will just expand this bracket, these both sides brackets. It will look like this. So 5 will go to the other side, this will, like, as it's in negative, so I'll move this to the other side. 16 cos is already there with a negative symbol, plus 8 minus 5. So it will be 5 cos square theta minus 16 cos theta plus 3 equals to 0. So now there you go, this was the requirement, and we got this thing. Now hence find the exact value of the second term in the series. So we need to find the exact value of the second term in the series. Okay, so for this, as like they are talking about the sequence geometric, so this is the geometric sequence, ar square, ar cube. So the second term is, this is the second term, we need to find this one, which means that a, we already know that this is a, and then r is, we know that r, what is r, what's r? R is 2 cos theta. So this is the second term, but we need to find the value. So what we will do, we will just factorize this. So it will be like this, I'm just factorizing this, minus 15 cos theta plus 1 cos theta. Now hold on, just a minute, hold on, this will be minus 1 cos theta plus 3. So taking 5 cos as a common from here, this will be left minus 3. So taking 1 as a common, nothing common here, so this will turn to cos theta minus 3, and 5 cos theta minus 1 equals to 0. Okay, so now cos is equal to 3. So it's not possible, we cannot, like, the value of cos, by putting any angle here, we cannot get a number greater than 1, so we will reject this one. So for this one, cos is equal to 1 upon 5, so which means we got the value, and we'll convert this sine square into, just a minute, okay, so we will convert this sine square into 1 minus cos square, and then this one like this. So we'll put the values here, and this one will be 1 minus 1 upon 5 square. This will be taking the LCM. After taking the LCM, it will look like this, which means that 24 upon 25 multiplied by 2 upon 5, 48 upon 1 to 5 is the answer. Okay, that's it.